Hello, everyone, and welcome to this WIOA 2021 Summit On Demand session. This presentation is titled WIOA Performance and the Statistical Adjustment Model, and we are joined by our presenter today, Brian Richard. Welcome, Brian, and please feel free to start us off.
Thank you. As Kirsten said, I'm Brian Richard. I'm with the Center for Governmental Studies at Northern Illinois University. My contact information will be provided at the end of the presentation. But I'm working with DCEO on developing the statistical adjustment model for the local performance metrics. I'm just going to turn my camera off for bandwidth purposes. Start the presentation. So what we're going to cover in this session is a review of the performance negotiation process that if you're with a local workforce area, you've already been through last year. I'm going to introduce the statistical adjustment model, give a brief example of how regression works, and then talk about how the statistical adjustment model, or the SAM, actually gets used in performance goals. So the local areas negotiated their performance targets last year, kind of in the August-September time frame. The factors taken into consideration for those negotiations were access to performance across the various local areas. The guidelines call for utilizing the statistical adjustment model estimates in the negotiation process. The model wasn't ready at the time, so what we did was just provide you with some trends in performance over the last several years for your local area, and trends in economic conditions and participant demographics and those kinds of things as inputs into the negotiation process. The WIOA legislation calls for promoting continuous improvement, so always trying to improve from year to year. So maybe looking at previous year's trends to kind of set a goal that shows some improvement from year to year. And the local areas also have to take into consideration the state goals. So, all of the local areas' performance adds up to the state's performance, and the state had already negotiated their performance targets with the U.S. Department of Labor before the local areas negotiated theirs. So this had to be taken into consideration to make sure that the state meets its performance goals. So I'm just going to briefly walk through the state's performance targets as they were negotiated with DOL. And for most of these, they were the same for the next two program years. They're both targets for both years are the same. So the employment rate second quarter after exit for adult participants is 77%, down a little bit for the fourth quarter after exit, 75.5%. Median earnings for those that are employed at 6,500, and you can see the rest. I'm not going to go through all of these step by step, but dislocated worker targets a little bit higher than those for adult participants. And finally, the third Title I program, youth. Of course, here we're looking at whether participants either enter employment or enter an educational program. See, about 73% is the target for youth participants. So both the state performance targets and the local area performance targets will be adjusted at the end of the program year using the statistical adjustment model. So the use of this model is required by WIOA. The language says that the negotiated levels of performance shall be revised to reflect the actual economic conditions and the characteristics of the population served using the statistical adjustment model. The Department of Labor has developed the National Statistical Adjustment Model. They use what's called multiple linear regression with fixed effects You don't need to know statistics to understand how this is used. I'll walk through that with you here over the next few minutes. And what the model does is it predicts performance, and then it will adjust the performance outcomes for each measure based on actual conditions and the mix of participants served. We're currently working on the Illinois specific model. It's not quite ready for public release, but we're using the same methodology that Department of Labor uses for the national model, just creating it so that we can adjust local area performance, again, based on those local conditions. And so the process, you've negotiated ahead of the program year, and then after the program year, those targets get adjusted. So it's negotiating up front, adjusting after. And what the goal of this is to do is to make sure the local areas are held accountable based on factors that they actual control, and they're not held accountable for factors outside. So you negotiate based on what you expect conditions to be in your case mix in the coming years. And then it's adjusted based on what the actual case mix is and what economic conditions are. And I'll walk through an example. This is all really high level at this point, but this is broadly what the statistical adjustment model is designed to do. So digging into the details a little more, we're trying to adjust performance goals to account for changes in participant characteristics, such as demographics, such as barriers to employment, so that if you're serving a set of customers with more barriers to employment, you might expect it harder to reach your performance goals. So the statistical adjustment model adjusts for that case mix, harder to serve case mix, so that you're not penalized for doing what the legislation says and serving those with barriers to employment. Economic conditions can also impact a local area's ability to meet their performance goals. Some employment sectors are easier for people to get employed in, so if those sectors are more prominent in your local area, your performance goals might be adjusted to reflect that. The unemployment rate also. If the unemployment rate is higher, it's going to be harder to get people employed. So there's adjustment based on the economic conditions. And the model really quantifies how these factors affect levels of performance. So it accounts for all of these factors and separates them from other factors so that your true performance is really only judged on the things that you can control as program administrator. You can't control what's going on in the economy. You can't control who's going to walk through the door. But what you can control is what happens once they do walk in the door. What services, choosing the appropriate services for each participant, putting them in the right type of training, giving them the right types of supportive services, giving them the best chance to succeed and improve your performance targets, getting them jobs, getting them well-paying jobs, those kinds of things. So the statistical adjustment model is really an attempt to judge local area performance based on what local areas can control. So I'm just going to give a brief description of how regression works. If you have a degree in math or statistics, the nice thing about a pre-recorded webinar is that you can fast forward through this part if you're not interested, if you already know it. You don't think you need to know it, but I think it's helpful to have at least a really basic understanding of how the model works. so that you can understand how it's applied to performance. So a linear regression model, a multiple linear regression model, has one outcome. So there's going to be a model for each outcome. There's going to be a model for employment 2 quarters after exit. There's going to be a different model for employment 4 quarters after exit, and a model for median wages, and so on. So there's one outcome for each model, but there's multiple predictor variables. So we're going to have, age groups. We're going to have gender. We're going to have race and ethnicity. We're going to have, the number of people that had barriers to employment. And of course, we're going to have variables for the economic conditions. And each predictor will have what we call a coefficient attached. So I'm going to walk through a very simple example of how regression might be used. So say we want to predict a person's weight if we only know their height, their gender, and their age. Well, if we collected a bunch of data, say we had 100 people and we collected their weight, their height, their gender, and their age, we could put all that data into a model and predict the weight, even if we don't know it, based on their height, their gender, and their age. So this is how a model might look. It ends up being this equation where weight equals the coefficients are the numbers with each variable, and then variables are the height, the weight, and the age. So in this case, our outcome variable is weight. Our predictor variables are height, gender, and age. And then the coefficients are what the relationship between each predictor variable and the outcome are. And then there's also an intercept in a regression model. And this essentially is what the model would be if all the variables were 0. In most cases, this has no meaning. Here, for example, if height was 0, gender was 0, and age was 0, our predicted weight would be negative 74.7. Of course, it's not possible. Nobody can be 0 inches tall. And so it's just a way of controlling for some of the variation in the data. So let's say we're predicting weight for a male who is 72 inches tall and 23 years old. So we plug our variables into our equation. So the height is 72 inches. So gender is an either-or type of variable. Call it a categorical variable. Either you're female or you're male. Most cases, most data sets, that's what is reported. And then, of course, the age is a numeric insult. So for this model, we set gender for male equal to 0 and female equal to 1. And so if we plug these in, height 72 times 3.2 is our coefficient for height, minus 34 times 0, so that's 0, plus 1.4 times 23 gives us a predicted weight of 187.9 pounds. So really what this is telling us is the average person that is 72 inches tall, male, and 23 years old, weighs about 188 pounds. So if we want to predict somebody who's also 72 inches, a male who's 72 inches tall, 24 years old, a year older, plug the numbers in, and we get 189.3. So here our prediction went up by 1.4 pounds. So you can see the age coefficient is 1.4. So the regression results found that for each year that an average person gets older, their weight goes up by 1.4 pounds. Similar with height. For each inch in height, each additional inch in height, the average person weighs 3.2 pounds more. And then, so for a given height and a given age, males tend to weigh 34 pounds more than females. So this is how those regression coefficients are calculated. Now you might take this equation and plug your own height, your gender, and your age into it. I did that, and it was way off. It was about, I think, 35 pounds off. My actual weight is about 35 pounds different from what the weight that this model predicted. So regressions results are not good at predicting results for individual participants. But if we selected 100 people, say, just collected their height, age, and gender, and plugged all of them into our model, as a group, we'd probably come pretty close to predicting what their average weight is. And so that's what the Department of Labor SAM model does. It takes all of the participants within a given year and uses the information from all of them, aggregates them, and then uses that to predict what the outcomes are. It doesn't predict what the outcome will be for an individual, because there's many other, just like there's other factors that impact the weight of a person. This model might work well, say, for US residents and not well for maybe Japan or some other country, or it might work well for certain subgroups within the population and not well for others. And so for our DOL, again, we're aggregating all participants and predicting outcomes as a group for each local area with our regression results. I'm going to stop sharing here and switch to sharing my screen to show some examples of actual statistical adjustment model results for Illinois. In my slideshow here. This screen. So here are some actual results from the Illinois Statistical Adjustment Model. So this was developed by the US Department of Labor. And so these results are for the adult participants for PY 2019. So so here we're looking at the employment rate second quarter after exit. So they used data from pre-2019 participants to build the model, to estimate these coefficients. And then they applied these coefficients to actual outcomes from PY 2019 to get the adjustment factor, what they call the adjustment factor for the performance goals. So you can see, we'll start here with the female. The coefficient is positive. So what you're looking for here is whether these coefficients are negative or whether they're positive. So a positive coefficient means that, higher proportion of customers that have this characteristic are going to increase your performance goals. So what this is saying is females on average are more likely to get employed in the second quarter after exit than males. So again, this is one of our categorical variables. When we have categorical variables that cover all participants, so all participants are either female or male, we only use one of them in our model. So this shows this is the difference between outcomes for females versus males. So females are more likely to be employed. But you see in the data used to generate the coefficient, about 58% of participants were female. But in PY19, the actual year that we're looking at, that percentage went down to about 55%. So because this is a positive coefficient, but the proportion of participants served actually went down that are female, the adjustment ends up being negative. So we'll look at some other examples. So we'll scroll down here. So you can see we also use highest grade completed at entry. So those that have less than a high school education have a negative coefficient. So these are folks that are harder to get employed in the second quarter after exit. So it's negative, but the proportion of those customers that have less than a high school education went down from 5.8% to 5.3%. So because this is a negative and it went down, that's essentially a double negative. So our coefficient is negative and the proportion that was served went down, so that's negative. So what it ends up being is a positive impact on the performance goals. This characteristic actually increased the performance goals. Trying to find one. So here, we'll look at the participants that received individualized career services. This is a positive. Somebody that receives career services is more likely to get employed. So this is positive. The percentage of participants that receive these services went up from the prior year to the current year, from 93% to 99%. So because this is a positive coefficient and because the percentage of served went up, both positives, that increases the performance goal. It's going to increase. So we have all these different factors. We have the economic conditions that all work the same way. The coefficients all work the same way and all have these individual adjustments to the performance goals. And what happens is we add all of these up, the positives, the negatives, and the total of all of these, the adjustment factor is all these different individual factors added up, is that we are adjusting the performance goal for Illinois for the employment rate second quarter after exit up by 3.6%. So how we can see that here is that Illinois had a negotiated level of performance for the employment rate second quarter after exit of about 77%. That was adjusted by the statistical model up by 3.6%, so moves it up to around 80%. Well, we can see that Illinois still met this higher level. They actually had about 80, 81 or 82 was their actual level of performance. So they exceeded the adjusted level of performance by 2.4%. They reached 102% of that. So this is what's important now to DOL, is how well the actual level compared to the adjusted level of performance. And this works same for median earnings. The adjustment factors are applied, a positive factor along with a higher percentage of that group served ends up increasing. It's a positive adjustment to the negotiated. And again, a negative coefficient with a positive served. This went up from 0.4% to 0.7, ends up being a negative adjustment to the performance. Again, add up all these positive and negatives, you end up at Illinois' performance for PY19 was adjusted from their negotiated level up by $874. So you can see that here. Negotiated level about 5,500, adjusted level 63, 6,400, somewhere in there, but their actual level was around 7,200. So again, they exceeded. It's not always going to be a positive adjustment. All of the adult program performance metrics got adjusted positively, as did the Wagner-Peiser. Trying to find one. So this is dislocated worker outcomes. So here you can see the employment rate fourth quarter after exit. Let's go look at the data for that. So here, again, just work through to see how each factor plays into the overall adjustment factor. But all these individual adjustment factors added up equal negative 3.34. So the adjustment factor is negative. So when you look at the results, negotiated at 79, but it's adjusted down to 76 or 77%. But again, still met, easily met the target with an actual level of 82, around 82. But if they had only, made 77%, it would have been below their original negotiated level, but they would still be shown as meeting the target because the statistical adjustment model negotiated, it adjusted down so that the target was actually lowered for this metric. So that's a whole lot of information that got thrown at you there. In a normal WIOA Summit session, this would be the point where I'd ask if there are any questions. And of course, I'm sure there are many questions. So instead of doing that, I'm going to share my screen one more time. And so this is how you can reach me. My email is brichard@niu.edu. So if you want to set up a time to go over this one-on-one, I'm happy to talk with you about how the process is going to play out for your local area. If you have questions about, you want to dig deeper into how the actual model is generated and all that, I'm happy to have those discussions. But for now, thanks for listening to kind of what can be a dry topic. Probably didn't think you'd be listening to a statistics class at the WIOA Summit, but this is something that the legislation, the WIOA legislation requires. And so this will be implementing starting this year for the local areas. And we look forward to working with you to make sure you understand how this is implemented and how it affects your local area performance.
Great. Thank you so much, Brian. And we hope you enjoyed this WIOA Summit on-demand session. And we look forward to seeing all of our attendees at the other sessions during the summit.